You guys hear me? All one of you? All right. Well, let's get this show on the road, I guess. All right. So as of the end of last stream, which I believe was last night, the days go together so quickly. We have this. Uh, just to recap, I've added a few extra bits. Like I built the guns and put them on there because we're not really going to be doing anything with the guns. If you wanted to, you could run LEDs in here, but for the purposes of this one, I want the weapons to be interchangeable. Like I want to be able to switch this one out to Helverin, which means the other guns. So these just twist on to the frame. They won't be glued on or anything stupid like that. Um, but yeah, just a few more bits and pieces, so it's looking like a robot. Where we left off last night was we got this servo that you can see in the hips right here. Yeah, the wire runs back through the leg and down into the base. I need to tighten this wire up a little bit more, but that's whatever. Um, and we got to the point where we have code that can rotate the torso, back and forth. Where we left off was we installed the LED right here in the eye. I don't know if you can see that because my camera is bad and only decides to focus on my hands. We've got that. You can see the wires up here that are sticking out for that eye. We have these two wires coming out of the base that we're gonna run up here to power this LED and to make it so that it can dim or turn off or whatever we need to do. So what we're gonna do tonight is get these wires routed up into here. I'm gonna show you how to kind of route them from the fixed part of the model to the rotating part of the model. Do that right, and then we're going to run about three more of these wires up the leg. So we're going to have a total of 5 wires going into the back of this guy. The reason I'm doing that is because I want to add a red, a blue, and a green LED inside the cockpit, inside the torso here. Because what I'm actually going to do with this model is kind of 3D print a window on top of it and set it into the chassis part that goes on top. And I'm gonna actually have a tech priest in there, so it's gonna be he's gonna be like completely interred in this thing, like it's his body now, and he's gonna have all these little lights and like levers and some mad scientist shit going on up there. So that's the plan. In order to do that, I need to run the wires for the lights, and I'm gonna put those on a little board so that we can more easily attach LEDs to it. But first, I need to start wiring up those extra PWM wires. And those, if you remember, we had looks like we soldered these wires. You're probably not going to be able to see this from this angle. To A1 or A0 for the motor and A1 for the LED. And we have another 2 pins here that we can use for the for PWM. But if we want to, we could also use some of these other pins. Like we've got an extra I2C bus pins on here that we can use. And like I said in the last video, we can tell the microcontroller to make these pins use any function. It is heresy. It's absolutely heresy, man. It's like the word. It's double heresy. But we can reassign these pins so that they, you could use these as I2C bus, but we've already got another I2C bus connector here. So I'm just going to use one of these pins and add 3 more wires here, and then we're going to reassign the SDA pin to be just another PWN pin. So yeah, let me go ahead and get started. this is going to be so there's going to be some programming in this stream. Like we're gonna once I get this buttoned up and get the all the LED wires routed up there. I'm just going to have some LEDs sticking out the top, and we're going to do some basic soldering, and I'll show you how this whole thing works with programming. So first off, I need to get some wire ready. You guys know how this goes. It's just going to be me chopping wire. All right, so normally I wouldn't want to use a red wire for PWM because that kind of indicates it's like a voltage line. But since we don't have a voltage line running up into the torso, I think we're fine. I'll just use that because I want to be able to distinguish which wire connects to which pin. So just going to chop off some lengths of wire, much longer than we actually need them to be, but you always want to go longer than you need it to be than shorter than you need it to be. So these are about 9 inches long. Should be plenty to get from the base, inside the base to up into the torso with plenty of slack. So I'm going to trim the end of these wires so I can solder them in. I'm going to heat my soldering iron up while I'm doing that. And then we're just going to real quick 1, 2, 3 solder these in. Keep forgetting I could just pull the insulation off these wires with my fingernails because it's so soft. All right, get these twisted so they go in the pinholes. I'm gonna trim them a little bit so they're easily solderable. I kind of need a new trimmer. This one's getting a little bit dull. I've trimmed things that I probably shouldn't be using this tool for, and it's dulled the blades on it. All right, so we've got our wire. The ends are off. So I'm gonna open this thing up. I'm probably not gonna do this on camera because y'all seen me solder plenty here. That, and I just want to do this I just want to do this quick. And I got to get this at an angle that I'm not going to be able to show you very well. All right, so soldering iron is hot. Solder is ready to go. Okay, so I'm just going to real quick, without too much yapping about it, I'm going to solder these on to the next 3 pinholes. Just verify that I'm doing the right pins. I'm just gonna flux these in right now because I'm just gonna do this pretty quick. And I know you guys can't see this, but come on. All right, that was in there. I'm going to add a little bit more solder to that one because it's a little bit iffy. All right, that's better. All right, so the next one is going in. I really should open my window for this, but we're already breathing in all the fumes, so. All right. In and out. Turn off the soldering iron. For now, just going to verify that these soldering joints look clean. Yeah, they do. They're actually pretty good for how quickly I did that. So just to remember, we put these on pins A2, A3, and SDA. So we've got 4 PWM wires coming out of this guy. A1, A2, A3, and SDA. So when we do our programming, we've got to remember that. So, all right, let us bundle these cables together and run them up a leg. So we've got the motor wire running up this leg here. Let me switch to bench. Where's my mouse? There it is. Okay. We've got the motor wire running up this leg. So we want to run these cables up this leg. So it's not, so it's not all on one leg because it can get a little bit bulky. So what we're going to want to do is, because we've got 5 wires that we want to run up this leg, we're going to want to kind of run them in different paths. So it looks, it's not just one big bundle of wire running up the leg. Another alternative that we could use is ribbon cable. But this stuff, if I can find it, got a whole spool of it. Is this stuff right here. I got this from a local electronic supply store. Yeah, I know. I'm not sure what the deal is with that. Just ignore it if you can. Anyway, let me actually reinitialize the camera if I can. Overhead. That still doesn't fix it. That's so obnoxious. I might need to switch from. No, it's just I'm using too many cameras or something. I don't know. Anyway, just I might have to switch to OBS because I'm using Twitch Studio right now, and I'm also using a bunch of cheap USB webcams. Anyway, you can use this stuff. It's reasonably flexible, and you can strand it out. But because I've got the silicone wire and I've already soldered in, this stuff's fine. I like using this for data buses. Like if I was to run an SPI bus up the leg or like an I2C, I might use this instead, because that way you can more easily keep track of which wire does what. So anyway, let's get wiring up here. All right, so I'm gonna put this stuff kind of right on the right behind this foot here. So I'm going to look at this, and I'm just going to have to drill 5 holes. I was considering dremeling a slot to put the wires through, but that's probably not a great idea now that the model's already standing on the platform. So I'll just push these holes through. It's not that big a deal. I'm just going to turn him a little bit. There you go. Might drill these in from the bottom. I'm just going to figure out where I'm coming through. I don't want to come through, under his foot or in one of his toes. That would be useless. All right, so from there I can see them. I'm good. So I just need a hole right next to that. And you want to drill these holes pretty close together. And the critical thing here is not to flex the base too much because you don't want to detach your robot from the base. Let me see where my holes are. It's looking good. Put one more. All right, so you can see kind of maybe the holes. Yeah, they're you can very see you can kind of see them right there. I don't think it's video. I don't think it's compression. It's video compression. It's probably just this computer being kind of junky. It's just a shitty HP that I bought off the shelf. You know, it's either that or it's just Twitch Studio being Twitch Studio. Probably once I'm done with this series, the next one I'll probably have switched to OBS just because that's not beta or alpha software like this is. So I'm snaking the wires up through the holes, trying to get a hold of them when they come out so I can pull it through. So just putting them all through there. And we're going to route these up the leg. Come on. Okay. So up they go through the holes. And you probably can't see much of this at all. But that's the reason why I haven't been streaming a lot of the initial batch of robots, is because it's very difficult to show the fine detail about what I'm doing, and so much of this work is just fine detail. Um, especially the soldering. Getting that microscope helped a little bit, but it's still, you're not going to be able to see a lot of what I'm doing because it's like this stuff where you're just pulling wires through all sorts of places and doing soldering. All right, so our wires are in pretty good shape. Just pulling up the slack from the microcontroller here, and making sure everything's good to go. I'm going to put some dabs of super glue on the bottom here, or actually I might put some electric tape or super glue then electric tape just to keep them. I don't want the wires to jerk and pull on the microcontroller. So let's just do a little bit of super glue. You can see what I'm talking about. This I want to put some dabs of super glue there so that the wires don't jerk and pull free from the solder points. You could also do this with hot glue, but I don't have my glue gun heated up yet, and super glue just works just as well here. Just kind of gloop it on there and dab it around a bit. And I'll let that set for a minute. And as you can see here, there's on the bottom, there's plenty of space to add other boards if you want to. Like one, for example, like this is this right here is a Adafruit Feather RP2040. It's a similar microcontroller to this one. It's just bigger and a little bit less capable, but it's got some neat stuff on it. Like this, it's got a battery charger built onto it, so it does what this bigger board and what the microcontroller do on the same board. It's not quite as powerful. It has very little RAM on it. I think it's like 256 kilobytes of RAM or something small. A little bit difficult to deal with Python, but I have other things like let me fetch one. Like one of these. It's in a bag right now, but I'm gonna open this thing. This is a soundboard. Now, there's a number of ways you can do sound with these with a microcontroller. You get a little I2S boost amp, which is that basically takes a digital output from the microcontroller and basically outputs sound into analog that you can just connect a speaker to, or you can use something like this. This is a basically a microcontroller in its own right. And what this does is it's got like 16 megabytes of flash on it and a USB port. You can just load sounds onto this, and it's got the amp, the sound processor on it, everything you need to actually play sounds. And it's got all these pins along the side here, and you can use these pins that if you signal one of these pins just with like pulling it down to ground, I think it is, uh, it'll just play a sound. Like it'll say, okay, we got a signal on pin 8, right? There's a sound assigned to pin 8, play that sound. Your microcontroller doesn't have to do anything. This just handles all of it. And that's all fine and good, but the real interesting part of this is that it's got a UART chip on it as well, or UART capabilities. So you can, just with 2 wires, you can rig it up to the microcontroller, and the microcontroller can tell it to issue commands to play files and stuff. So you can have, if you do it with just the pins, you're limited to the number of pins that you have on here that you can use as triggers. But if you do it with UART, you can just be like, you can have hundreds of sounds on here and you can just play them as whatever you want. It's basically a self-contained sound card. And then you could put a speaker on it. I may do that for this one. I've just got to decide what sounds I want it to make, if any. And then, of course, you'd have to put like a surface mount, like a speaker on the other side of this board. But I've got a bunch of small ones. That's fine. Anyway, back to what we were doing. I'm going to put a little bit of electrical tape over those things so I don't accidentally apply wet super glue to something it shouldn't touch. Oh, come on. Electrical tape's being awful right now. Come on. All right. Just putting a little electrical tape over those wires. And that's not going anywhere. Yeah, just to keep things clean. The more crap I shove in here, the more potential there is for short circuits, like something touching something else that shouldn't be. So electric tape's your friend in this situation. Okay, so that's wrapped back up. Just gotta put this back on so the wires don't stick out that are already in there. And I'm gonna probably go in, and when I clean this up, I'm gonna tape these wires down or glue them down or something so they're a little bit more contained. But yeah, now we've got this big bundle of wires. We gotta route up the leg. Now, again, we want to make sure we don't route them around the front here, over the ball joint, because that's where the front armor plate for the ankle sits. But there's no other, and also we don't want to route them around this part here, because there's an armor plate that sits right on this part. So we kind of want to bring it around the back of the leg, and through some of the features on the back of the leg, like this loop here in the plastic. And I'm just gonna fold his little little arms up so that we have room to work with here. That is definitely not what an armored. This is heresy. That's not what an armature is supposed to look like. Okay, so let me just see if I can get these wrapped up and around. And you can get creative. You don't. They don't. All the wires don't have to follow the same path. You know, rule of cool applies. You can make. You know, you can think about these wires like props, right? You can make. It's just more stuff to make this look all gnarly and cyberpunk or whatever you want to make it look like, or ancient machinery, because that's kind of what it is. These things are thousands of years old in the lore. So I'm just going to snake these wires like 2 at a time up to these different paths to make it look cool. And the key here is just to avoid the armor plates or the places where the armor plates will be. If you don't know where those are, look at the instruction manual for building the model to make sure you understand. But I've built half a dozen of these things now, so I kind of know where they go. And the goal here is to get these wires up to about here, to about the hip. And we're going to want to attach them somewhere, either by glue or by some other means, so that they're anchored solidly to something on the bottom here that's not moving. So that way, when we have the loops that attach to the upper torso, they don't, the wire is solid, so it's not like jangling around. Because again, we're going to see some repeated movement here against these wires, so we want them to be solidly anchored and not come loose or self-destruct in the process. So I had one of my original models that I did this to. Actually, one of the wires came loose because I wasn't paying attention, and it was flexing on a solder joint. So you had bare wire that was flexing, and part of the reason why we have insulation on these wires is to prevent metal fatigue for when they flex. So it adds some additional support. And if you flex the same piece of metal over and over again in the same direction, you'll get metal fatigue and the whole thing will just crack apart. So we don't want that at all. So I'm just going to run these wires around through this loop with the first two. And just going to pull these through. And this is really the last bit of wiring we're going to be doing for this whole robot. The trick's just to get it in there solidly, attached to something solid, glued on, so that we can attach it to. We can make it a pivot point. So you can kind of see here what I'm going for. I've got these wires in the back kind of lined up flat against the motor housing here, or the servo housing. It's hard to see with my hand in the way, but like that. So basically I'm going to put some super glue there to hold these flat against the servo housing, and then loop them up so that they attach to they go in this little, there's a piece that goes over here, but I like using this little cylindrical part to drill through the back of that and have the loop coming out the back. So I'm going to get these glued down, and you can use, again, super glue or hot glue here. I think I'm going to go the super glue route just because I don't have the hot glue gun out. And the wires are relatively well behaved here. But flip him over, so gravity on my side. Alright, so I'm going to get these wires up. I'm just going to put a mess of super glue on the side of the servo. Kind of spread it around a little bit, and then kind of lay these wires flat here and kind of press them onto the glue. Let them, I want to hold them for a minute or two because I want this to set really well. So so just wait for this to set. Alternatively, you can zip tie these wires to some feature of the model if you can find like a cable loop big enough, or if you want to attach a zip tie. It's there's no one way to do this. The key, just whatever you end up doing, you want the wires to be on there pretty solidly, because as the robot turns, they will be flexing like this. So you want them to be super glued on there tightly. So you want them to be packed, and sometimes I even put like some additional fluid super glue on top to like really get them in there. And these silicone insulating wires don't always like to stick to super glue. So they're sticking now, and now I'm gonna put some additional super glue on top, just to like the fluid stuff, so that we can, that'll get down in between the cables and bind them to each other, not just to the servo housing. We just want these to be on there like rock solid, because otherwise they'll just start flapping in the wind, and that's never a good idea. Again, when messing with the liquid superglue, stuff goes in any cracks it can find. Keep it away from your servo, like any openings on the servo. You don't want that getting into your gears, because that will wreck your servo, and that would be a bad thing at this point, because we're really far into this build, and wrecking the servo is just, you're almost scrapping the model at that point, or tearing the legs off of it, and rebuilding the entire servo assembly, and yeah, it'd just be a total mess. So we're just waiting for that liquid super glue to cure a bit. It's gonna be a minute or two here. While we're doing that, I can show you a bit about this big one that I made. This is the first project I made. This is the Knight Castellan. He is a large robot. Just gonna move this camera back all the way. This one's pretty cool. He's actually running a full-on Raspberry Pi 02W, which is like a quad-core machine with like 512 megs of RAM. It's a big computer for this, but he does a lot of stuff. It's booting up now. This one doesn't turn on instantly. Sensors online. Weapons online. All systems nominal. A little bit of a mech warrior call out there. This one is 6 servos. You've got one in the waist. One, it's not in the waist. It's actually inside the torso, because these have a lot of room inside the torso. You've got 2 in the shoulder. You've got 1 in each shoulder and 1 in each elbow. So you've got one. The shoulder servos are actually inside the torso, and those connect to an outside shoulder servo, or elbow servo, I should say. And this one's got a whole menu on the back with a little LCD screen for controlling it. And I'm setting it to manual right now, so it doesn't move on its own. And it's got to flush its movement buffer real quick here, so that's why it's still moving. Oh, the head was extremely difficult to get working, because there's no space behind the head to put a servo. So what I had to do was put a servo like an inch behind the head, and then have the head marionetting with fishing line. So there's a bearing above the head, so the movement is nice and smooth. And then there's like 2 little prongs on the back of the head that have fishing line attached to them. And then there's the servo with little arms on it that pulls the head back and forth. It's it's overly engineered and overly complex, but the result, it looks really cool. So there's also, let me show you the control panel on this guy. So this is it's got a little 1.3 inch LCD screen on it. You can see here. And that LCD screen shows the thermal camera output from the front of this thing. You can see my hand waving around the front, because it's got a thermal camera. Um, yeah, it really is over engineered. It's the name of the game here, but this one is engineered to the point of insanity. There's so much shit on this thing that's really not needed. Like I put this thermal camera on. That's one of the most expensive components. That's like an $80 thermal camera. It's just an I2C bus thermal camera. Um, Man, these cameras are really flickering. I need to figure out what's going on with that. But you can see on the little display here, it shows some information about the positioning of of all the servos and also the thermal camera. But you've also got this little joystick that you can manually control the movement, and the arms go up and down, and it goes left and right, and you've got 9 LEDs on 3 PWM channels inside the plasma eradicator. So these kind of march back and forth. I wanted to make it look like the warp core from Star Trek Next Generation. And then on the board, you can see this little thing back here. This is actually an I2S amp, which is like that digital sound interface that I talked about earlier. And that allows us to play a number of sound effects. And the speaker on this thing is a 40 millimeter. It's got a lot of depth to it for being a speaker this small. But it's got the war horn. I'm assuming you guys can hear that. And then it's got the firing gun, the gun firing sound for the plasma gun. And it does a little bit of lighting effects for that. But programming the lighting effects on this thing is it's not easy. It's kind of annoying, but whatever. Finally, we got this volcano cannon here. This is actually dangerous. Uh, Inside of here, there is a 3 milliwatt green laser. I had no idea what I was doing when I built this. That 3 milliwatt laser will burn your eyes out. Like the little ones I use on the other model over here, those are 1 milliwatt lasers. This is 3 times powerful than that. If I were to turn this on all the way, two things would happen. First, anyone who looked directly into it would be seeing spots for days, and this probably would start to melt because there's no heat dissipation inside this weapon. There's no airflow. The laser diode sits in a little 3D printed collar in there. So what I did, since I don't want any of that to happen, is the laser is controlled from a PWM line. You know, running. There's actually inside the top of the head of this thing. I'm not taking the. Actually, I can take the lid off because it's not soldered. It's not glued on. Come on. There we go. It's got magnets to hold it on. This is what it looks like in the inside. There we go. Yeah, it over-engineered just a little bit. This has got 2 8-channel PWM boards in it, and they're sitting on top of each other, sandwiched. The bottom one controls all the servos, and the top one controls all the LEDs. So you've got multiple channels of LEDs on here. You can see that the ones on the top that kind of make it so that it lights from the inside, and then you've got these in the exhaust, and you've got the eyes, and then you've got the front lamp, or the front lamps on these right here, and then you've got the ones in the weapon, and you've got the laser. So there's just so much shit going on here. It's and this was my first robot. This took months to build because I didn't really have I didn't really know of all the tricks to do it properly. That's why I can build these other ones so quickly, is because I learned all the wrong things to do the hard way on this. Um, yeah, absolutely. There's a Reddit post. Let me find that. It's got a good demo video. Give me one sec. But yeah, this thing is. I kind of wanted to go to, at the risk of sounding politically incorrect. I went full retard on this thing. Um, I didn't know what I shouldn't have done, and I just kind of did everything. So yeah, I mean the idea was to make it so that this thing could track targets using heat, and it can. It is extremely difficult to actually make it track one target because the thermal camera, the longer this thing is on, the more waste heat dumps out of the chassis into the camera. So it gets noisier and noisier, and it just starts tracking ghosts. I mean, maybe there are ghosts, maybe it can see the ghosts and we just can't, but it's not reliable enough to really, and you'd have to do it right. You'd have to do a lot of like computer vision, like open CV implementations on a Raspberry Pi. I mean, you can totally do it, but it's just a little bit ridiculous because again, when you're playing with this on the tabletop, you don't want it tracking targets and melting faces off. It's just you just can't. Because if this thing's moving around on the table, it's gonna bump into things and just be a mess. Um, Let me give you guys the Reddit post. Yeah, if you want to see a demo video of everything this guy does, that's a good place to start. But yeah, let me get back on topic here. So this guy's going to sleep. He's just got again the base. Well, one more thing here. The base is this is cool. This is a bit more complicated than the base on that we're using here. This big thing is just a lithium polymer USB battery. This is neat because it's only a quarter of an inch thick. I mean, these are new. I haven't seen these before. I don't know how long these little quarter-inch thick batteries have been around. Um, but what you've got here, I've got a just a surface mount male USB plug here, and then the wires run around here to just another modular connector. This is a standard female port for USB. The reason I do that is because I want to be able to replace this battery, so it's all modular. I could take these wires off if I really needed to. This is a 5 volt to 3.3 volt buck converter. Basically, it's a power converter that steps down the 5 volts from the USB because this outputs like 5 volts at 2.1 amps, which is great for powering USB, but it sucks for powering logic level stuff and LEDs. So I've got this steps the power down to 3.3, and then these power connectors. Two of these are for 5 volts in the ground, and then the other two are for 3.3 volts in the ground. So those wires, and then there's a power switch here that just cuts the ground wire to the battery, effectively turning the whole thing off. And then these wires run uh, up into the. You can see if I can get the angle right, ribbon cable running up the leg here, and then ribbon cable here. This is the flex point for the torso. You can see that flexing. This is just that same uh, DB9 serial port wire. This is actually serial port wire from an old PC. I salvaged a lot of weird parts from all over the place to build this thing. And this contains, let's see, this is all, there's power here. There's 3.3, there's 5, there's ground, and then there's 2 wires for I2C. Um, yeah, the I2C bus powers all. I2C bus controls all of the PWM controllers in the top, and also the thermal sensor here. The thermal sensor is actually interesting because it uses so much bandwidth to send those images back down the bus that I was running into bus contention issues. Like it was taking too much of the time to transfer each image. And I'm trying to move the robot to have the robot be able to move while it's doing that. And it was taking up so much time that I couldn't get the movement to be smooth while I was transferring thermal imagery. So I had to make it only capture thermal imagery while the robot was not moving. So some design compromises, but I mean it's not much of a compromise. that robot probably cost better part of like $500 to build because I had to go. I fried a bunch of hardware building it and made a bunch of mistakes and had to redo a bunch, and yeah, it was a bit of a mess. That was every aspect of this I was learning while I was doing that project. I didn't exactly start small, but anyway, I think our wires are solidly on there. Yeah, they're good. Okay, back to our original programming here. I'm just gonna put the align this so the wires are in there, and cool. So now that we've got these glued to the now that we've got these wires glued in here, we're gonna work on getting these looped up and into the torso. So when you loop these wires like this, you always kind of want to mock it up a little bit, like just kind of put your thumb here and see how the torso turns, see how the wires flex, see if you've got enough slack. You want to make it so that the robot can turn 90 degrees in each direction. So yeah, just put a bit of a loop here. You can see there's quite a bit of slack. Um, so what I'm going to do now that we've kind of figured out that yeah, this is good, I'm going to drill. I don't know if you can see. There's a little gap right here, a little opening in the model. With the regular model, there's a little cap that goes over this. It's like a cylinder battery pack, but I put all my stuff up through here and then just cut a slot in the cylinder so it fits on there. And I secure it by just mashing it full of green stuff. Um, the battery, yeah, man, that's a 5,000 milliamp hour battery on the big one. That can serve that lasts a long time. Like I have to recharge it like every once in a while because the Pi Zero 2W really only uses like maybe 50 or 60 milliwatts of power, or it's not milliwatts, milliamps. Uh, so yeah, it can really last a long time. Uh, if you're running the servos constantly and like just having the more movement the robot makes, the more power it uses. But generally, that's the servos for that one are not going to be running all the time because I don't want it thrashing around because it's so big. I also didn't know how to put it together properly, and I have a lot of spring couplings in there, which means the servos aren't directly coupled to what they're turning. They have a spring in there, so it acts like a shock absorber, and it also allows you to connect to a servo to something that's slightly off axis to it, so it's a bit fragile. Like these guys that I'm building are all direct coupled, so they can thrash around. The servos can move as fast as they want, and that uses more power. But anyway, yeah, the TLDR that battery's good. That's a big battery. Um, and finding a battery that would fit in that form factor was difficult because most USB uh, battery packs are like round or they're thick or something. They're not designed to fit inside of another application. All right, so what I need to do is drill a bunch of holes here into the model. I'm going to try and drill. First, I'm going to clamp this thing down so it doesn't come opening up while I'm doing this because I don't want that opening anymore. All right, so that's just got a C clamp on there. Probably a bit too big, but it'll hold the model still while I'm drilling. All right, that's pretty secure. All right, so I'm gonna just go in here. Oh, there it goes. I'm gonna drill. This is a bit unstable, but I'm gonna drill a bunch of holes here, and that these will come up in the bottom of the model. And it's important here to not put too much pressure on the model itself because you don't want to snap anything that you've built, like our servo assembly. This is why we add a bearing to the model, so it's stronger. I would feel real nervous about doing this on a model that didn't have that bearing assembly. Because you could do something awful like snap the top off your servo or something like that. But I'm all right with doing this like this. Ideally, you do this before you attach the torso to the servo, but here we are. Just gotta be careful. One more hole. All right. So probably again, you probably won't be able to see this, but there are now 5 holes, and that those holes go right up into the. Yeah, it's gonna be tough to show those, but yeah, okay, there you can see the holes there. Wire's just gonna go right up in there, and then again, we're gonna repeat the process by super gluing those in. Or you can use green stuff and just stick a big wad of it in the butt of this thing and right up in in that kind of gap just to seal it up. The goal here is just to make sure the wires are in there tightly. We want them to be anchored by their insulation, not by the metal and the wire, because the metal will fail if you anchor it directly like that, or have rotational forces be on the metal itself rather than the insulation. Okay, so I'm just snaking these wires up through here. And we want the loop, the wire loop, to be kind of neat. So we might even put a zip tie on it, depending on how. Once this thing starts moving, if like if the flexing is uneven, we want to bundle it together so it kind of shares the load, or like is the load's more unified. We can do that, but for now, I'm just gonna stick these wires up through here, and we'll see what that does later when we actually start moving this thing. So I want to keep these kind of even, make sure the loops are the loop will allow this to. Yeah, we've got a couple of these wires are pulling out when we flex, which is fine, but yeah, zip tying these might be the way to go because we want this to flex uniformly. It's not bad, but you can see how this would work. Uh, you've got enough. You want to have enough play in these wires so that you can rotate the body completely from one side to the other as far as the servo will go. And once you have those, that kind of calibrated, we can glue the wires down. And you do that the same way as we did it before. Just kind of get in there with some super glue, and I'm going to do it from this side because it's easier to get to the holes. Just make sure your wires are even. Really just slop the super glue on there. Normally less is more with super glue, but sometimes you just gotta put it, really slop it in there to make sure it gets in all the cracks and holes you want. And then I'm just gonna kind of hold this for a second to let the super glue set, make sure the cables are in place. Oh, you guys can't see any of that because I'm off camera. All right. Well, this is what it looks like. These are kind of in there. I'm gonna let the glue set for a minute. And while I'm doing that, I'm gonna show you kind of what I'm gonna be attaching these to on the inside. Um, since I'm gonna be adding a lot more LEDs, you can usually run, depending on your microcontroller, you can run 3 or 4 LEDs, and depending on the amperage of your LEDs, you can run 2 to 3, sometimes 4 LEDs off of one PWM line without it starting to brown out. PWM lines don't usually have a lot of voltage to them or a lot of power, a lot of amperage, so you've got to keep that in mind. Uh, these I think supply probably like 20 milliamps per channel, which is enough to run maybe 1 or 2 LED, 2 LEDs probably max. So what I'm going to do is once those wires are secure, I'm going to solder them onto this. I'm going to put this on the microscope so you can see that there's a bit I want to show here. Come on, bits. Oh, hey, my microscope is this. Twitch Studio doesn't know what it's doing with all these cameras. I got to refresh devices constantly. Okay. All right. So this is a strip board. So what this does is you've got four. You can see there's 4 rows of 4 pins or holes, and there's these you can see the little band connecting the rows of holes. That's a conductor. So anything you solder into one of the pins here, that signal or that power will go to all of the pins that are connected. So what I'm going to do with this is I'm going to trim this down a little bit so it'll fit inside the narrow torso, and then I'm going to put the ground wire here. I'm going to put one of the PWM wires directly to the LED in the head because I don't need to split that at all. But the other 3 PWM wires that I added, I'm going to put one of them on each of here. That way I can solder the LED wires directly here without having to have some big clusterfuck bodge solder with a bunch of LED wires going into one wire. This just makes it easier to build. So let me trim this down. I'm going to cut this useless part off. I mean, there's a screw hole here that you can use to screw it down, but I want this to fit into the torso. And, well, you can't really see that there, but let me switch to... So the torso is pretty narrow. This camera's reversed, so maneuvering around is really irritating. You could fit it kind of like this, but it's still a little too wide. So I'm going to snip it. I'm going to snip the screw hole part off of it so it's smaller. And that's going to go all the way in the bottom of the torso. Because what I'm going to do is I'm going to have a little guy. I've got a engine seer tech priest that I'm going to have sitting on top of it. And he's just going to be in here to what extent I can put him in there and kind of controlling the thing like some mad scientist. So, yeah, let me get this thing trimmed. Where are my trimmers? I'm just giving this a snip. It's kind of dirty. There we go. So yeah, this looks like this now. It's not the cleanest, but it's smaller. And if I really wanted to, I could snip the other end of it off as well. But I think it's small enough. All right, so now that we've got our wires all up in there and relatively solid, I'm going to start to solder. So this can get awkward because the wires, especially the black wire here, we don't have a lot of slack. So this is going to be, I'm going to have to solder it from behind. So let me turn my soldering iron on. This is a lot easier than some of the other soldering scenarios we were doing. And the goal here is to solder each of these wires into its own strip on this board. You want to make sure you don't solder all the wires onto one strip. I've done that. It causes an immediate short circuit. So let me get this through, and then we'll start soldering. And we'll be soldering our LEDs into that board as well. Just get this wire twisted and good. Make sure I'm lining up the pin strips right. All right. So I'm just going to solder that little thing right there. Soldering it from behind is not too bad. It's pretty easy. Just a little flux, little solder. And hopefully this will be the last soldering step on this bot. You just want a nice solid connection here, so the solder goes through the hole. Yep, easy. Let me get my fan set up. I just don't want to breathe this crap in here. So for some of these other ones that I've built, the ones with lasers and all that other stuff, this little circuit board, it's got a circuit board like this in the head, but it's also got things like its own buck converter up there because I'm running 5 volts all the way to the head, because I'd be running like multiple servos through the torso. It's really, really tight. There's transistor, like laser power boosters, like every surface in here will be a circuit board, and there's servos everywhere. But this one's just going to be simple. So we can just have one little PWM distribution board up here. And, if you wanted to, you don't have to put this board in. This is just optional. I like doing this because it makes the design a little cleaner and easier to debug. You can have these wires linked directly to your LEDs, no problem. There's nothing wrong with that. I'm just going to be doing a lot of LEDs in this thing outside of the scope of these videos for my own build. Because this video really only covers having the one LED and the one servo. But I'm just showing you how I'm going to be doing it for the rest of the project. So remember, our yellow cable is the one that's going to connect to the eye here. So, and what I'm going to also do is I'm going to use I just soldered in the black wire here. Let me get my fingers out of the way. The black wire soldered in here. That's our ground wire. So I'm going to use that. I'm going to solder. You can see those little holes on the strip there. I'm going to solder our ground wire or negative wire from the LED into one of those holes. So it just uses the ground wire from there. And then I'm going to solder the positive wire of the LED directly into the yellow cable, just because we're not controlling any other LEDs from that. And it's all common ground, so you can use the ground over and over again. This gets a little complicated. I'm making this a little bit more complicated than this build needs to be, but that's just what I do. So let's get to it. I'm just going to verify the direction of the strips here. Cool, they're vertical. All right, so I'm just going to go ahead and take our negative LED lead, put it through one of these holes, and then solder it in. And, always check to make sure you're soldering where you think you're soldering, the right wires and so on, so you don't make a terrible mistake and have to redo it. All right, so flux that. catch some solder here. Come on. Get a nice bead. And then just gonna patch that in. Nice. All right. So that LED ground wire, the LED negative wire is on our ground bus here. Trim the little lead off because we don't want loose wires everywhere. You know, you don't have to trim the excess wire off your boards or off your solder joints, but again, doing it just saves you some pain later because if it touches something it's not supposed to touch in shorts, you'll be hunting for that short. It's a dumb thing. It's a simple thing you can do to solve a complex problem later on, potentially. All right, so that's in there. Let's get the yellow wire soldered directly to the LED so we can just power this puppy on. I want to make sure that I am not using too much space in this torso for wires. So I want to make sure our cable routing here is good because I've got a lot of crap to shove in this thing later on off stream. So I'm going to put this all the way back here. So it can be, so this can be, these wires can be folded down in the back here of the torso. So I'm going to pinch this off. Come on, there we go. Twist this together and then get some solder on it. All right, that's pretty solid. Just going to flex this so the solder runs in. I probably overuse flux a lot. You know, some master electrodes will probably tell me I'm doing it wrong, but it works for me, so I don't care. And I'm just going to put some solder here. All right. Just going to clean my solder tip here. It's getting a little bit nasty. You get flux and crap and melted insulation on your soldering tip, and it starts turning black. But now you can see kind of that it's all silvery because I wiped all the corrosion off of it in the build-up. So okay, so at this point we've got our LED PWM wire all soldered up, and we've got the ground wire from the negative lead to so you've got the ground lead and the LED soldered into the ground, the negative lead and the LED soldered into the ground wire, positive to the PWM, which will be supplying our power, which is great. I'm going to put a little bit of electrical tape over the end of this thing, just so it doesn't come into contact with anything else. Let's wrap that around. And then this is getting shoved all the way to the bottom of the torso, hopefully never to be seen again. I'm just going to curl this back and just stick it in there. Really, all of this wiring is going to get just shoved in here because I don't want to. It'll have to be rearranged probably when I put the engine sear into the torso, but for now it just goes back there. All right, so the rest of these wires need to be trimmed and added to their respective strip here. So I've got 3 wires and 3 strips, so that's good. I'm going to trim these down to size, and then get the insulation off, and then solder them in. It really doesn't matter which order these go in. I'm gonna try and assign. I've got a red, a blue, and a green wire here. I'm gonna try and assign those to their respective red, blue, and green LED that I'm putting in here. But I'll have to check which pins on the bottom here they're assigned to, and do it accordingly. But it doesn't really matter. This is all going to be glued together eventually, so that no one will need to look at it. I mean, debugging it might help debugging a little bit, but if something goes wrong, but once these things are together, they usually stay together and stay working, so you don't have to worry about it breaking. But I say that, but then that guarantees it's going to break. All right, so I'm going to start putting these in from behind, so I need to twist the wires. All right. And it gets a little bit finicky when you're dealing with something this small, and with this we cut off most of our slack here, so getting these wires to go in where you want them sometimes requires tweezers. I'm going to find my tweezers. Alright, so I'm going to take these tweezers and kind of put the wire through the hole. We want to make sure we don't have any wild fibers running off these wires, because that will cause a short circuit, and that is really not what we want here at all. Oh, there is. Yeah, I just double checked, and there's one here. I didn't twist the wire all the way. You're not going to be able to see that, but there's a extraneous fiber of the wire going off to the side that did not go through the hole, which means that has the potential to short into another one of the pins and cause the whole thing to stop working. So I'm going to twist these extra carefully to keep the. And you can avoid this by using solid core wire, but solid core wire doesn't flex very well, so it's not great for this application. But if you're doing just a static installation where it's not going to be moving, you could probably use solid core wire just fine. All right, let me just check to make sure we've got everything ship shape here. You don't want to have to debug one of these boards after you've soldered it. It's really obnoxious. I'm going to take this over to my other magnifying glass, or actually I can use my magnifier here. Maybe. Okay, let's see if I can get a good angle on this thing. I'm going to take it to the real magnifying glass. I've got a big 8-inch magnifier and an arm over here that I use to check these things. It's easier to see. And I'm really glad I did, because I have an extraneous fiber coming out of my ground wire, which I could not see with my bare eyes. So I'm going to clip that if I can. Just get it out of the way as best I can. And now I'm going to try and get that red wire in there without cleanly, without having the little fibers all over the place. This is this could be tedious. It's probably not terribly exciting to watch, but welcome to building robots. All right, let me recheck that. All right, that looks good. So I'm going to solder that in. Make sure the strips are oriented properly. They are I have to do this 3 times, so hopefully the second and third time aren't such butts. Okay. So my soldering iron went to standby, so I'm going to let that warm up again. All right, so get the right angle to here, and that's not what I was looking for. Okay. Perfect. Nice clean solder joint there. And let me trim the ends off that so it doesn't short anywhere. I could do that once I've got them all in. All right, so next I want to get the green cable. Let's repeat this entire obnoxious process of twisting the wire, getting it through the hole without, cleanly, and then soldering it. And this gets more annoying the more wires are connected to it because it's kind of stiff. But this is worth doing because it'll make wiring the LEDs to this board a lot easier. Come on. All right. I'll check this again. That's clean. Just gonna solder that. Apologize for my bench cam not focusing well. It is just a webcam for doing teleconferences, and it doesn't know what to focus on when I have it this close. There, I mean, it'll temporarily focus until I put my hand over here, and then it'll focus on my hand. So it's really not optimal for this. I need to find like a fixed focus camera I can use, but that's another thing for another day. All right, so we're gonna go ahead and put some solder on here and solder that in. We'll only be soldering for a few more minutes here, and then we'll move on to showing what you can do with all of this stuff with code. All right, so that looks good. Nice solder joint there. Now for the last one. The blue wire. These are all PWM channels still, so just getting them in the right holes. All right. Double check what I'm doing here. Yeah, okay, so we're gonna put this last wire in the last hole. I can already tell that's not going to work. There's the twist is already starting to fray. Twisting wire this small is kind of tough. All right, so that's in there. I'll give it a check real quick. Yeah, looks good. So Yep. Don't do that. All right, that's good. Got smoke lingering in my model here. All right, so our board is looking pretty solid here. We've got all four of those wires soldered into their respective rails. I'm going to trim the excess wire off the top, and then we can fold it over and start and give it a test. So you can see that is maybe not. I don't know. You depending on how. Anyway, those solder joints on the top there are nice and clean. They don't have any extra wire sticking out of them, so it won't. We won't be shorting out anything here. All right, so we're gonna flip this over so we can actually do work. Work with it if we want to. Um, Come on, there we go. So as you can kind of see there, we've got one of each. We've got the black wire and a rail, the red, blue, and the green. Um, from here, I can solder LEDs with the negative pin on the ground rail and the positive pin on one of these PWM channels. It just makes it easy to add LEDs to this thing. But that is something we're going to do later. I can add, if we really want to, I can add an LED here. But for the time being, I'm just going to leave this for when I finish this mod. When I finish building the robot completely off stream, because there's a lot of work for what I'm doing. There's going to be a lot of work left. But this is here for when I do that work. So I'm just going to kind of fold this back in here, and then we're going to turn this on. We're going to hook it back up to the computer and turn it on to make sure this eye still lights up, because that's what we did here with all this wiring. One of those wires is the eye. So let me hook it up. Hopefully no smoke, no fire. And it's on, so that's good. That means my wiring is good, the eye turned on. Let me start up Moose so we can do some coding. Come on. Get in the right window. Oh, jeez. I've got different monitors running at different resolutions on this machine, so it's things jump around a lot. But yeah, okay, so here we are. Moo. Moo as in the Greek alphabet letter, not moo as in cow. So, all right, you guys can see the code. I'm assuming it looked good in the VOD, so I'm just moving my keyboard over here. I'm gonna turn off my soldering because we're done there. So, yeah. So what can we do with this now? I'm gonna just put the. So what are we gonna do with this now that we've got a robot? This is about as far as we're going with the robot. So let's do some stuff with it. All right. So I'm deciding whether or not I want to steal code off of one of the others. We've got our PWM controller code here, and then we've got our LED code here. So I think we're just gonna roll with it. Okay, so we've got our servo here. Let's set this up on a loop to rotate back and forth. Let's give that a try. So I'm gonna say we want this to run forever. So I'm gonna say while true. So this runs in. This will be our loop for x in range 0, 180, and we want it to do 3-degree increments. Actually, I'm gonna set this to be like 10 and 170 because I don't really want to jam the servo to its full extent. So this is gonna go from 10 degrees to 170 degrees in 3-degree increments. So I'm gonna take this right here. I'm just gonna copy this and keep our indentation right, and then say X. And then we don't want to set if you tell a servo to go to a specific angle, it'll snap right to it as fast as it possibly can. So we don't want this loop to just thrash our servo. So I'm going to put a little time sleep command here for 0.03 seconds. That's a good value that I found that kind of keeps the servos smooth. And every servo is going to be different, so you might have to tweak this a little bit. And then I'm going to copy this entire chunk here, and we're going to reverse the motion. So we're going to go from 170 down to 10 at a -3 increment, and it's going to look exactly like that. So let's see if I actually got this right here. I'm going to kind of brace a little bit on the base in case it starts thrashing. So let's take a look. I'm going to get my serial output so I can see if I botched the code. And here we are. Just so you can see that a bit better here. And you might be able to see it. I don't know what the frame rate looks like on your end, but you can see that it's a little bit jerky. Like it's not like a nice smooth motion. And the reason is you've got to calibrate these based on the amount of weight that it's rotating, which is going to be different for every model. It's just really complicated to get the motion to be smooth. The point is that it's smooth enough. You're not going to damage your servo doing this. It's not going to go thrash, 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 thrash back and forth. It looks like a reasonably smooth motion. And, I could do something like changing to 0.04 on the sleep or something. And, it's going to take a little bit of... Okay, so that's a little bit smoother, but the motion is slower. So you've got to, you've got to work with it. You want to get... The key is to try and find the balance between that delay and the increment which you're rotating. So you want to catch the servo right as it's finishing one movement to give it another movement. And that's going to be servo dependent, and it's going to be dependent on the amount of weight you're rotating and the resistance from the wire. There's a lot of factors here. The TLDR, you're going to have to mess with it. This is a pretty nice motion. Like, it looks nice and smooth. It looks realistic for the robot. You got to remember, these things are like 30 feet tall in lore, and you don't want them having, snapping back and forth, moving like that. It just isn't realistic. You want it to be a nice controlled movement. So we've got that movement down pretty well. And this is going to continue doing this while it's on. For the big one, I have some random delays put in there. Like, it'll turn to a degree, it'll sit there for a second at a random interval, and then it'll turn to another degree and it'll sit there for a second. So it's kind of like, it looks like it's patrolling back and forth. But this is just a good test pattern that shows the extent of the movement that we're going to get here. You can also see on the behind the robot, if you will, how the wires are flexing. The super glue is holding pretty well, but I'm still going to put some green stuff into that gap here where the wires are going to the torso, just so I can give it a little bit more strength. But yeah, I like the way this turned out. We used the exact right amount of extra wire for the loop. And this is, again, the reason why I'm not turning it to the full extent, because I don't want to put too much pressure on it. But this is working really well. This guy's looking good. Just turn him back, face the camera. All right, so let's do something with the LED though. I'm gonna wait till he is in. I'm gonna stop the code just by pressing Control C. Okay, so we did something with our servos, right? Perfect. So I'm gonna comment out this code. we're going to keep that because that's good code. But what if we want to do the same thing with the servo? So I'm going to grab this for loop here. Keep pressing my Mac copy keys, rather. My Windows copy keys. All right, so we grab that line, put it right there. We say X in range of 0 to 32,000, or yeah, let's do 32,000, and then have it step in increments of 1,000, right? Okay, cool. We're going to take this same loop. We're going to take that there and basically follow the same pattern where you're stepping up and then you're stepping down. And this should produce an effect where you are dimming and where's my LED call here? Where did I put that? What was it? One moment. I don't have the I don't have this stuff memorized on how to do the LEDs. So I've got to. Oh, there it is. Cool. Okay, so let me put this in X. All right, cool. Let's see how this looks. Make sure he's in focus. All right, so if this works the way I want it to, that little LED on the front should pulse on and off slowly. And is it doing anything? Hello, computer. Is this actually working? Okay, that's weird. All right, I must have messed something up here. Oh, hold on a second. I know what it's doing. We forgot to add the sleep command here, so it's just going so quickly that we can't actually see it changing. Let's give it a. Let's slow this down a little bit. This should take about 3.2 seconds to go through each of these cycles. See if this does anything different. Okay, so it's getting brighter, and now it's getting dimmer. Can you see that on camera? Yeah, all right. See, we can do all sorts of weird things with this, and we can set it to any dimness we want. We can set it to any pattern of flashing or blinking that we want. But yeah, that's how PWM works. Let me see if I can get that. Am I going to be able to get that on the oscilloscope? Let me pull the guts out of this thing again. Hold on. Hopefully I'm not breaking any wires. I'd really like to show what this looks like on the oscilloscope. That would be cool. I already taped it all down. Basically, if I was to show this on the oscilloscope, if you remember what that looked like yesterday, you'd see the pulse widths getting wider as the light turned on bright, and then get narrower as it dims. So the wider the width, the brighter the longer the duty cycle, the brighter the light. The narrower the width, the shorter the duty cycle, the dimmer the light. But okay, so let's combine these things. So we want to have the LED kind of. Okay, well, the way I'm doing the code, I'd have to write a for loop that kind of multiplies the X to have them in the same to be synced up. But you get the idea. You can have. There's nothing stopping you from actually, let's see what I can do about this. Let's see. Get my calculator up. Of course, it goes far away in another monitor that I can't see. All right, so 32,000 divided by 180 equals 177. So, oh, all right. So let's try this. This is going to be a bit faster movement than what we were seeing. X divided by 177, which I believe is the, and this might not work. Yeah. Okay. Well, let's see what happens here. All right. Yeah. It didn't like that. The this went below like the threshold or above the threshold for if you give the if you tell the servo to switch to an angle that's above 180 or below 0, it throws an exception. That's what happened here. We probably went like 181 or something, but you get the idea. You can tell the servos to do things while the LEDs are doing things. It's all independent. None of these are tied together. So it's just a matter of, writing code that's set up to do it, which I really tried to hack just now and didn't really work. But yeah, this is pretty simple stuff. And I've got my LED here set up to run off of pin A1. I could have LED 2 set to run off of A2, LED 3 off of A3, and so on. And then I would do that last one to the SDA pin, because I set that. So we'd have 4 LEDs. All of them are independently dimmable. It'll be pretty cool. I'm going to set the servo to move again. So yeah, that's ladies and gentlemen, we have a working robot. And this one's pretty simple. He's he's going to have a little bit more. He's going to have 3 more LEDs at least. But you can use the stuff we learned here that I showed you how to do to add more servos, because if you look at the code, all you have to do to add more servos is add, you get more of these lines. We call our servo PWM. That's just the channel it's on. So you set the servo up here, telling it it's using the PWM object that you create here. You could just set up, and if you have more servos on different pins, you just tell it which pin you want. You have one of these lines each for each one, so you can have as many servos as we want. So if I wanted to have a second servo on this thing somewhere, it doesn't actually exist because I haven't added it to the bot. But I would do this. If I had that servo on pin 2 or pin A2, I would do that. Do this and just call it PWM2, and then make another servo object. My servo 2, and then we could issue commands to that servo as well. So that's how I have the ones with the armatures with 3 servos in there, having their arms move around while the torso is moving and while the lights are doing things. It's all Python. It's all very easy to learn. But yeah, let me clean this code up and then I'll post it on GitHub with all the STLs and parts lists for this thing, so that you can do this at home if you're insane and hate yourself. Right. So yeah, this is I'll leave this code in here at the very bottom. This is for, let me just add some labels or some comments so people know what I'm doing. But yeah, the same principle applies to LEDs. You're just making a new LED object, telling it what the pin on the board it is on, and then off to the races you go. You just manipulate it by setting the duty cycle variable. And obviously, there are different types of servos that you can use. Uh, like the ones we're using here are very small, and they're not very powerful. But I've got these other ones here. I gotta find these. D51R. Right. So the one I'm using here is a very lightweight servo. It it doesn't have a lot of torque, and the gears inside are made of nylon. So if you were to put way too much resistance on this thing, it would either freeze up or it would strip the gears out eventually. You don't want to abuse these things. So what happens if you want to have like my big robot that's up here, where the upper part of it weighs a considerable amount of weight? You can't use this little servo to turn that because it's just not enough power. So instead, what I use is this. This is a metal gear servo. It's got metal gears in the inside of it and a much lower gear ratio, and it's got a metal pin. It's got a metal spline here, so that this can handle a lot more torque than this little one here. This one, you can't. If you try to stop it, it's difficult to stop from turning. So that's what I use for like when I'm building my big ones up here. That's what I'll be using for the torso twist, just because it's a lot more weight and you want it to be a bit more substantial than these little plastic ones. But yeah, for the arms and the arms and the elbows, or the shoulders and the elbows and the head, the little tiny sub micros will do just fine. So let me finish up this code, and yeah. I'm just gonna switch to code view here. Here we are. I'm just adding a little bit of documentation here. Yeah, that'll do it. All right. So I'm going to take this piece of code and just drag it up onto GitHub real quick, and then I will link that for all of you who are watching at home. Just bear with me here. I'm doing things on my other tab. Okay, so if anyone wants to see the code and all the STLs associated with this project, I'm going to go ahead and link this in chat. And this will also be on YouTube, linked in the description of the video when this gets uploaded to YouTube. So that is how you make a robot. This guy is good to go. I mean, there's no real. I mean, all the wiring is good. All the programmability is done. I mean, I'm obviously going to go back and add a bit more code to make it do some more sophisticated behaviors, but this is done. Maybe clean up the wiring here, and this is going to have some other stuff in the head. So but for our purposes here of demonstrating how to build one of these things, we're good. The next steps will probably be, you can choose how you want to seal this. If you want to screw it, if you want to put magnets. I prefer putting magnets to lock the top of the base to the bottom of the base, so that way I can get in there to get to change the battery, or if a wire breaks or burns out or something, I can replace components. But that's up to you. Um, some people might want to glue it, but that's whatever floats your boat. It's up to you. There is no one way to do these things. So that's it. Please, if you have any questions, just let me know. I'd be happy to help. I'd love to see more people doing these out in the community. I know it seems really intimidating to do based on what I've showed here with all the soldering, but it's really not that bad. It just takes a little bit of practice, and a lot of learning. That's the big thing about these. So I think I'm going to wrap up for the night, and because we're pretty much done here. And yeah, let me know if you got any questions. I'll be happy to help. I'll probably be doing some more streaming coming up. Maybe not this week, but I want to paint this guy and get him all sorted. I might build another one with the servo and the head, because I have plans for this guy and another one with the servo and the head. So I may build that on stream. It won't be like an instructional stream. It'll just be me fucking around with the robot, going as fast as I can without talking. Uh, but yeah, I guess I'll see you next time. Thanks.